here's Hadoop case use case, then you'll be able to understand what exactly has. See, YCS is going all of a Hadoop. Okay, big data implementation CS case study. This will
Okay.
really help you. What has been done? What are the scenarios? How exactly this has helped with respect to this big data, and what are the challenges that they have faced, and what is the cluster they have used. This is the thing that you can see. And the other
Great.
thing what you can see is that how Hadoop has helped people,
Okay.
to detect as well as to investigate Boston
Oh, okay. Okay.
bombers. So this will also see Boston Marathon Bangles, how big data has helped to find out those particular, victims are the people.
Right.
Okay,
Right.
this also
Right.
will help you. So like that, you are having, and one more thing, within Apache itself, there are all the case studies that are available who have registered with respect to Apache. You'll be
Okay.
able to, maybe I'll show you in the next session, who
Okay.
are all the people who have registered with Apache. Okay, in
Okay.
terms of how many nodes they have implemented, as well as what are the maximum number of nodes within the cluster. The complete information is there within this particular case studies also. I'll share you so that you'll be able to understand what type of applications are expected from this particular big data Hadoop, and then how exactly you would like to focus is something that you'll be able to understand. Okay,
Okay. Okay. Sure.
so
Sure.
that's why it is going to help you in that particular case.
Similar
Okay.
to this, are there any deep dives? For example, like if we have a 100 node Hadoop implementation, of course we cannot be going and installing the OS in each one of the data node. So the idea is like we get the configuration from one node and then copy the configuration across the 100 or 200 nodes, the
Exactly.
host configuration, etc. So are there any tools to do that? And are there any deep dive notes which you can share, Ravi, for that?
Sure. I have all the notes regarding with respect to the Hadoop administration. Okay,
Okay.
uh, uh, how to set up a multi-node cluster. Okay, how to set up a multi-node cluster, and what are the precautions that we need to take for the purpose of setting up that multi-node cluster. Everything I'll
Yeah.
be sharing you. There shouldn't be a
Okay.
problem. And what are the
Okay.
configurations that you need to set up and the parameters. Those things also I'll be sharing you. No issues on
Sure.
that one.
Okay. Okay, Ravi. Sure.
Yeah. So yeah, that is one thing, and we have who are the other guys we are having here? We have. Let me tell you.
Yeah, Ravi Cameron is here.
Hi, Kamran. How are you?
I'm good now by yourself.
Yeah, doing good. We have Jawhar, who is from India, right? And who is this caller one? I really don't know. It's okay. Who is this caller one? Are you able to view my screen and all? Caller one?
Other one is, I think, Murli, sir.
Murli, yeah?
No, no,
I think
caller one is not Murli. Murli, my name is there.
You are using your mobile also, right, to interact with the trainer?
Not the mobile. My other phone, so landline.
okay, got you. No issues.
Maybe caller one is someone else.
It's okay. Whoever it is going to be. But yeah, guys, let us start from the place where you have stopped yesterday, and I will take it forward. Uh, let me. So, what is that one? Is Sarvanan, yesterday we started dealing with this particular Hadoop architecture. Let me try to take a brief overview of what exactly has been covered, and then we'll take it from there. Okay. So see here. Yeah. See here. Hadoop. See, Hadoop is having two things that we need to talk about. One is stated as the HDFS, which is nothing but the Hadoop distributed file system, and second thing is nothing but the MapReduce. So while we are talking about this particular Hadoop, we need to talk about both this HDFS along with this particular MapReduce. Okay, now uh, let me tell you a couple of things here. HDFS is basically used for storing the data, as well as MapReduce is used for processing the data. Okay. Now, uh, what are all the features of Hadoop? What we are talking about? I told you yesterday that there are three objectives that we need to fulfill. What is the first objective here? It can have the probability. It can have the probability to scale up to any amount of data. Might be in terms of terabytes. It might be of petabytes. It might be of petabytes, as well as it might be of zettabytes also as well. Okay, kindly hold on please for 1 minute. Okay, so it should be of terabyte, petabytes, or zettabytes of data. And what is the second thing that we are talking about? The second thing what you are talking about is nothing but the failure capability, right? The second thing that we are talking about is nothing but the failure capability. So what do you mean by this particular failure capability? Whenever you take a cluster, when that cluster is having something like a multi-node system, even though if one of the node fails, automatically what should happen is within no time we should be able to spin up the other node, and then the whole storage and processing has to be transferred to the other node as if nothing has happened. That is what is called as the failure capability. Can anybody tell me what is the third one? It is something programs need to be transferred. Data should not see processing need to happen. Processing need to happen at the local nodes, basically at local nodes, at the data resident systems. Data resident system. That means that I really am not intending to transfer the data across the network, but the programs need to reach to that particular data for the purpose of local processing. So these are the three objectives through which this particular Hadoop has been devised. Okay, so the earlier distributed systems, in the case of the networking file system or the storage area network, fail properties. Hence, what has been done is that big data has been introduced to address these particular three concerns basically. Okay, so you have this particular HDFS as well as you have this MapReduce. So first, we are talking about this particular HDFS, and we'll be continuing today and tomorrow on this particular HDFS, and MapReduce is something that we'll start seeing from Monday. Okay, now let me tell you what exactly is this HDFS architecture. The first thing is that you need to have a client. You need to have a client. Okay, that we are talking only about the storage, guys. Mind you, we are talking about only about the storage. Okay, the client is having something like what we can say is that some 300 MB of file that is existing here. MB of file. We call this one as a sample file here. We call this one as a sample file. Let it be any type of data. Okay, one thing I want to tell you, Big Data Hadoop can have the option of processing any type of data, be it be structured, unstructured, or semi-structured data. Okay, so it can have the option of taking any type of data that is coming across. So you have this particular 300 MB sample of data here in this particular case, and I want to store it in a particular system, right? I want to store it in across the network. So So one thing what you're expected to do is that you're expected to have two types of you're expected to have two types of nodes. What is the first type of node what you're having here? The first node what you're having here is nothing but the name node, and the second type of nodes what you're having here are nothing but the data nodes. How many data nodes you can have here? There is no any limit that can be imposed on this many number of data nodes should exist. As the Sarwan is talking about, I can try to make up a 100 node cluster, a 1000 node cluster, or a 10,000 node cluster also I can do. So that's why there is no limit. Okay, but obviously the place where your data is expected to be ultimately residing, that particular node is always treated as the data node. And what is the other name for this data node? The other name for this particular data node, they are nothing but they are generally treated as the slave nodes. They are generally treated as the slave nodes. Is it clear, guys, what I'm talking about here? They are generally treated as the slave nodes in this particular case, and this is what is your data node 1, and here you have this particular data node 2, and you have this data node 3, node 2, and then you have this particular data node 3. Okay, so now tell me, what is the first step here? We want to store this particular 300 MB sample in this particular 3 nodes. So what the first step that should happen? Murli or Jawhar or Kamran, anybody can tell me. Client should approach this particular name node for the purpose of asking this particular 300 MB of data has to be stored in all these particular systems. Okay, so what the name node should do? The name node should try to find out the free space in any of these particular nodes. The name node should find out the free space in any of these particular nodes. Okay, and a couple of things that I want to tell you here. And this particular file, what you are having here, will be splitted into blocks. The file name what you are having here will be splitted into blocks. What are those particular blocks here? Each block should be of 64 MB to 128 MB size. It should be there here. Okay, you can have a default size of 64 MB, but you can also configure it to 124 MB also as well. So that means that 300 MB sample can be splitted into, assuming that it is splitted into 3 blocks. That is sample 1, as well as it is splitted into sample 2, as well as it is splitted into sample 3 here. So this is what is called as the logical splitting, the physical splitting what we are doing here. Okay, and the client or the end user is not aware of how these particular blocks are getting splitted, but ultimately they are going to be splitted like this. Okay, once the client split these particular blocks, once the name node split these particular blocks, name node will be telling the client sample 1 has to be stored in node 1, sample 2 has to be stored in node 2, as well as sample 3 has to be stored in node 3. Like that, it starts telling basically. It starts telling. So that means that how can it tell? It need to tell that there should be some free space that should be available in node 1. There should be some free space available in node 2, as well as there should be some free space available in node 3. That means that the dynamics of this particular 3 slave nodes should be available within this particular name node in terms of how much is the space, disk space of node 1, disk space of node 2, as well as disk space of node 3, and among that particular disk space, what exactly is the free space that is available. That complete information about each and every data node, okay, is being maintained at this particular name node. And then what we do is that we call that particular information as the metadata information here. Metadata information. Sarvanan, you are following? Sarvanan and Jawhar, you guys are following? Or any questions you are having? Please tell me. This name node maintains the complete information about this particular 3 nodes in this particular metadata node in terms of how much, what is the total disk space, how much amount of free space is available, and based on this particular information, name node will tell this particular client go ahead and then store this particular sample 1 in node 1, as well as sample 2 in this particular node 2, as well as sample 3 in this particular node 3, like that it will tell.
So sample 1, sample 2, sample 3, what you're essentially telling is that 128 MB block
Yeah,
chunks.
these are the blocks. These are the blocks. Okay. And in other terms, what we can do is that we can also call them as the file splits. We can
File
also
spread.
call them as file splits basically. Okay.
Okay.
The number of file splits is nothing but equal to the number of blocks that file is being splitted into basically. Okay. So accordingly, it is being stored here.
So how will the metadata look like? The metadata will look like file ID, file name, and the block.
It looks like this. Let me show you like this.
Okay.
The metadata information is going to be, I have this particular sample file, okay, sample file, which is split into S1, which is split into S2, as well as which is split into this particular S3. Okay,
Okay.
S1 is initially stored in node 1,
Okay.
okay, as well as it will be stored in node 3 also as well. Can you please tell me why this is being stored in node 3? As I
That
have
is
told you,
the
failover capability,
Right.
replication factor.
Right.
Okay, failure capability. At any point of time, even though these particular nodes are failing, there is always an 100% probability that node might fail at any point of time. Okay, in such a case, what we need to do is that we need to transfer the entire data and processing to some other node by setting up instantaneously. So that is the reason we'll try to maintain this particular replication blocks. Okay, the replication factor by default is going to be 3. Okay, the replication factor by default is going to be 3. So that means that if you have a file of if you are having a file of what you can say 300 MB, okay, obviously how much space is required? 900 MB of free space is required for the purpose of storing that particular information. Okay, and one thing you need to understand here, at any point of time, okay, more than one block, sorry, the replication of the same block cannot be stored on the same node. So that means that on this node 1 itself, I cannot store two replications of the sample one. Why? Because that will not serve any purpose, right, Murli?
Right.
Yeah, right.
That's why all the replication blocks have to be stored in different name nodes altogether. All those replication blocks has to be stored in different nodes altogether here.
So what happens, Ravi, if we have only 2 data nodes and then replication factor we set it as 3? So it won't follow
We
the
cannot set like that. We cannot set it like that. Okay.
Yeah.
Even if you try to set it also as well, the purpose is not being solved, right? The purpose
Exactly.
is not being solved, right? So we don't want to set like that basically. Okay.
Okay.
That means that there is also a rule. The number of replications factor what you are going to have should be less than or equal to the number of data nodes that are available in that particular cluster.
Okay.
That is the major baseline that we maintain for the purpose of maintaining this particular replication factor here. Okay.
So in the metadata, I'm pretty sure the block address will also be there, right? In the metadata.
Obviously, yes. The block address also will be there.
Okay.
And see, the block address, at what address it is being stored, these are all internals into this particular architecture, right? But
Yeah.
from the client point of view, we really need to understand the high-level logical split that is going to happen, and what are the dynamics that are happening between each and every node. That is something that we need to understand from the architecture point of view. If we
Okay.
are really doing a deep dive into the admin process, then yes, that should be the place where you need to really focus on that particular piece basically. Okay?
Okay. Sure.
Yeah. Now a couple of questions will be coming here. First thing is that how should the name node knows that node 1 is having this much amount of total space among that one among that particular space how much is the free space and how much is the utilized space? How should it know? Okay, and I also have told you something like failure capability. That means that if a node fails at a particular point of time, that means that if a node fails, at some point of time, okay, how does that name node knows that that particular node has been failed, so that it can start initiating the process to some other node? How is this something that is going to happen is something that we need to really understand. Okay, for that particular purpose, what is going to happen here is, see here, this is your name node, this is what is your name node, okay, and assume that these are your data nodes. These are your data nodes. And in this particular data nodes, what is going to happen is you have something called as the blocks of information that is being maintained. Okay, I'll say you something like it is nothing but the file 1 block it is being maintained here, as well as file 2 it is being maintained, as well as file 3 it is being maintained here. Okay, and again in this particular node, what is happening is that file 4 is being maintained, that is a file split. File 5 is being maintained, as well as file 1 and file 2 are also being maintained here in this case, block 1 and block 2. And similarly, in this particular third node, what is happening is that you have something called as file 4, as well as file 3, as well as file 1 is also being maintained in this particular case. Okay, so that means that this is how the data node 1 is attached, this is how this data node 2 is attached, and this is how this particular data node 3 is attached like this. Okay, now this is going to maintain this particular information like this. This is the name node. This is the name node what we call here, and then this is what is called as the metadata, and the name of this particular metadata is what is called as the FS image. That is a file system image what we call here. This is what is stated as the file system image. Okay, what is being maintained here? You can say something called as sample, which is being split into how many splits? F1, F2, F3, okay, F4, and then F5. These are the splits that you are having here. Are the splits that you are having here, and F1 is residing on which node and which node? It is residing on name node 1 along with name node 2 and name node 3. That is N1, N2, and N3. Name 1, name node 2, and name node 3. It is N2 and N3 it is existing here. And then when you take something like F2 for that particular, Jawhar, are you following? Jawhar, Murli, and Kamran.
Yeah.
Yes.
And we have something called as F2. F2 is being stored in node 1. F2 is being stored in node 1. It is also mentioned in node 2 like this. Like that, this information is being maintained in this particular metadata here. Okay, and how this particular metadata is being maintained? The metadata is being maintained only in this particular name node like this. Okay, now the question is that how does the name node knows that a particular data node has been failed? So this is DN1, this is DN2, this is DN3. Last night I was telling you, what I was telling you here, every time, see, for every 3 seconds, these particular data nodes are supposed to send a heartbeat to this particular name node, saying that, hey name node, I'm alive, and then I'm storing this particular data, as well as some process is running in my node. So that means that heartbeat interval will let the name node know that this data node is still alive, and then it is in working condition. Okay, now and one more thing. So that means that what it is happening here, for every 3 seconds, a heartbeat is being shown. For every 3 seconds, a heartbeat is being shown. And also for every 30 seconds, what happens is that a block report is also being sent. What is that particular heartbeat and what is this particular block report? Can anybody tell me?
Heartbeat is just okay. It's just to say I'm.
Yeah, heartbeat is just to say that I'm alive, Block report means in this particular data node, this much is the space, and within this particular space, I have utilized this particular space, and within this space, these are the files that are available. Okay, and this is the free space that is available. That information is going to be sent to this particular name node from each of these particular data nodes. Okay, and based on that particular block information that is being sent by this particular name node, and what FS image is going to do, FS image is going to change those particular block settings based on the information that is being received from each of these particular data nodes. Is this point clear to everybody, or do you want me to repeat? Please let me know. Very, very important.
So so block report means basically it is telling the name node that I have totally this much space available, this much free space. I am storing these files, and in each one of the files I am storing these blocks.
These blocks, yeah. That information has to be given from each and every name node. So from each and every data node to the name node. Okay. And one more thing is that by chance, if the name node is not able to hear the heartbeat for a certain amount of time, what happens is that it assumes that particular data node is dead. It assumes that a particular data node is dead, and what it will do is that it will automatically transfer. Suppose a particular program is processing this particular F1 block, okay, and that particular block one is not available now. So that means that right now what is happening here, this particular data node is dead at this particular point of time. You agree with me? This particular data node is dead at this particular point of time. Okay, now what we need to do is that we need to transfer. That means that obviously what I need to do, since this is not there, the process which is manipulating this particular block one has to be transferred to this particular F1 of data node 2. Correct or not, Murli and Sarunan?
Yeah.
Can you please repeat what you said, Ravi? Actually.
Yeah, what I'm saying is assuming that this data node 1 is dead.
Yeah.
That means that it is not this name node is not receiving any heartbeat signal, as well as it is not able to receive any block report also as well. So that means that it certifies that this is dead.
Yeah.
Now what should happen? We are talking about the failover capability, right? When we talk about the failover capability, what should happen here? This data, suppose a process at that point of time is processing F1 block. Okay, that means that since this is dead, the process also will die, right?
Right.
Now, this name node also should allocate some other process. Okay, should initiate that particular process to rerun that particular F1 block once again, right? To rerun that particular F1 block once again. So that means that where is that F1 block? It is available here as well as it is also available here. So, so which one is nearest to this name node? Assuming that this data node 2 is nearest to this particular name node. So what happens is that whatever the process that has been stopped on this particular data node 1, okay, will be eventually be shifted to this data node 2, and then what it will do? It will start processing that particular F1 file, F1 block file once again.
Right.
Guys, is it clear to you? Murli, Sarvanan, and all the other guys?
Yes.
Okay.
So basically, failover capability is there even at MapReduce. That's what you're trying to say.
Yeah,
basically.
Failover capability is there even at MapReduce as well as even at storage level also as well. And one more thing that you need to understand. If this particular data node is dead, what does it mean? Right now, what is your replication factor here? The replication factor is only 2, right? F1 is being maintained only twice. So in such a case, what you need to do, it should automatically initiate one more data node.
Right.
Okay. And whatever the blocks that has been dead, it should start writing here in this particular data node 4, and within this data node 4, this thing has to be entirely copied onto this particular name node at this point of time.
Right. So let's suppose we have 50 data nodes. So if the replication factor of 3, that is the most common replication factor. If one data node dies, obviously one of the blocks. So from the dead node, those blocks need to be returned to one of the existing 49 data nodes.
Exactly.
So as to maintain the replication factor of 3.
Yeah. It should also maintain that same replication factor, irrespective of whether the node is alive or not. It should automatically maintain that replication factor. That is the de facto standard. This big data architecture is expected to maintain.
Okay. One question, Ravi. Why all the material is telling that the replication factor of 3 is ideal? I mean, I was reading that generally 3 is kept in most of the installations. People don't change it. Why is that?
See, let me tell you one thing. Yeah, very good question that you asked. Let me tell you. Suppose if you are having a database of size 100 GB.
Yeah.
Okay. Do you really use this big data concept?
No, in RDBMS we don't use.
Yeah. See, the point where the RDBMS techniques or the data warehousing techniques are expected to fail.
Yeah.
Okay. That is the place where big data is expected to kick off.
Right.
That is the place where big data is expected to kick off. Point number 1.
Yeah.
Okay. And the second point, what we need to really understand is it something that can be achieved within a single node itself, the big data? Hadoop or the open framework has to be really distributed, right?
Right. Yes.
The information has to be really distributed.
Right.
Okay, that is one thing. And second thing is that if it has to be really distributed, we cannot do it on a single node. Okay, we need to have minimum 3 nodes. Why? Because one node can be, at least 4 nodes we need to have. One node should always be used for the name node, which obviously is expected to act as a master.
Yeah.
Okay, which obviously is expected to act as a master, and the other 3 nodes what you are having here should always be existing as the data nodes, basically data nodes, which is of different types of storage here. Okay, now the reason is that these particular data nodes what you are having here are not the high-end supercomputer machines with the highest configuration.
Correct.
Because the data nodes always are expected to be of the commodity hardware.
Right.
I hope everybody knows what exactly is this commodity hardware, right? Commodity hardware, like
inexpensive hardware.
Inexpensive systems are nothing but the commodity hardware what we call here.
Yeah.
So that's why. So during this particular high throughput and high network traffic, what happens is that there is always chance that one node will obviously crash at any point of time.
Right.
So that is the reason what they do is that whatever the data that is there obviously will be replicated in the other 2 nodes also as well, just to ensure. So that is the reason what they do is that they'll try to keep it as a de facto standard of 3 in the minimum configuration for the purpose of maintaining that particular harmony across this particular minimum configuration nodes within this open distributed cluster server node. That's the reason they specify that default replication factor as 3.
Okay, so it's basically a balance between performance and availability. 3.
Yeah, it is a balance between the performance, availability, network throughput, and the cost of each and every node within that particular network, basically.
Okay.
For this particular reasons only, this what we can say, they specify that replication factor and the block size. Can anybody tell me what is the default block size for the Windows file system? What is the default block size for Windows file system?
Is it 8 KB or 32 KB? No, 8 KB.
4 KB.
Okay.
4 KB. 4 KB.
Yeah.
Okay. And one more thing is that why what is this one? Big data framework or Hadoop framework is having the default de facto size as 64 MB. Any idea?
Because we are doing analytics processing, we want to read at one read. We want to read a lot of things. So analytics crunching requires that record size be high with a high time.
Yeah. Let me tell you. The smaller the block size, okay, the greater the number of reads that are expected to happen for the purpose of reading all these particular files.
Right.
Okay. So the larger the block size, the smaller number of splits that will help you to read all this particular data in a sequential manner. Okay. And one more thing, this is clear to you, guys.
Right. Yes.
Murli,
Yes.
is it clear? Murli and other guys, Jawhar and Kamran.
Yes, clear.
Can you please repeat once? This is Murli.
Okay. See, the smaller the block size, suppose if you are having let me tell you with the help of the example that will help you to better clarify. If you are having some 100 GB, 100 GB file, okay, and what you want to do is that you want to split that particular file into blocks of some 10 KB, as well as you'd like to split that particular file into a block of some 64 MB. 64 MB. I'm not going into max basically. Tell me where you are going to get the maximum number of file splits, in 10 KB or 64 MB, Murli?
10 KB.
Okay.
10 KB, you're going to have the maximum number of splits. Okay, assume that the maximum number of the maximum number of files are going to be here 100, and here assuming that it is going to be something like some 20 or so, 20 or so in this particular case here. Okay, now if you have a disk, in the disk, what is possible? The random access is possible, right? The random access is possible. Right, Murli? You can access any file at any point of time. Like, let me tell you here. Suppose if you have this particular file split, which is on FS1, which is on FS2, as well as which is on FS3, directly if you want to go to this particular FS3, this is possible in the case of normal operating system. Okay, but in Hadoop, if you want to go to this particular FS3, what you have to do? You have to do only the sequential read. That means that you initially need to go to FS1, then you need to go to this particular FS2, and then eventually you need to go to this particular FS3 here. So that's why if you want to get into that, so that means that what we can see here, if you want to increase your read efficacy, or else if you want to increase your read performance, do you tell me whether we need to have the more number of files split across the network or less number of files split across the network, Murli?
Less number.
So we need to have the less number of files split across the network. So if we want to have the less number of files split across the network, okay, my question to you is, what should be the block size? Does the block size need to be small or it should be large? Please tell me.
Large, yeah.
The block size should always be large. So that is the reason, okay, Hadoop framework or HDFS framework always tries to maintain the larger block size. It can be of 64 MB, or else we can also have the option of trying to configure in the form of your 128 MB also as well. Right?
What is the most popular, Ravi? 64 MB or 128 MB? What is the most popular?
128 MB is most popular. 128 MB is most popular across multiple implementations. 128 MB is popular.
Okay.
Why?
Okay.
Because see, when you start processing your data in the form of the streaming files and all, obviously what happens is that I really don't want to split them into multiple smaller chunks. That is the reason I try to maintain some larger chunks. That is the reason 128 MB is basically popular, especially for unstructured and semi-structured data. 128 MB is popular, but for structured data, people split it in the form of the 64 MB basically. Okay.
Oh, okay.
Okay. Now, let me tell you a couple of more things also here as well. So we are trying to maintain this particular larger file splits here. Okay, that is one thing that you have seen now. Now, let me tell you a couple of more things also as well. Let me tell you a couple of more things here. We have seen the block size. We have seen this particular file split factor, as well as we have seen how these heartbeat intervals are coming and what is the block node and what is this particular things we have seen now. Okay, and now let us start focusing on this particular name. I also have told you that the data nodes what you are having here is of commodity systems, okay, which are a bit of less expensive when compared to the high-end configuration system, okay. But in this particular master-slave architecture, which one is the most powerful node that we can call? Is it the name node or the data node?
Name node.
Name node. So far, we are always saying that data nodes can fail, and data nodes can fail. But what happens if the name node fails?
It is a single point of failure, basically. At least in Hadoop 1.
Yeah, in Hadoop, this name node is always treated as the single point of failure. Why? Because why it is treated as a single point of failure is that if the name node is down, okay, the client or the end user, client is always a different entity case. The client at any point of time will not be able to access any of these particular blocks, will not be able to access any of these particular files. Why? Because the entire metadata, the core information about these particular things is being maintained only at the name node only, So that's the reason what we really don't want to do is that we really don't want to mess up this particular name node. But obviously everything is inevitable, right? The name node also might fail also as well. So here, for this particular name node, when it is trying to maintain this metadata, okay, it is going to have two types of files that is being maintained. Okay, I have already told about the first file. What is that particular first file that I was talking about? Guys, can you please tell me what is that first file called?
File system image.
Yeah, FS image, that is something that I'm calling here. This is the FS image that I'm calling. And the second thing what you're having here is generally treated as the edit logs. Okay, so who is giving the block report? The name node, the data nodes are giving the block reports, right? This is the name node. Okay, and this is the data node that exists here. This is the data node. Okay, this data node is trying to give the block information to this particular name node. Okay, so what it says is that, let me tell you one thing. Earlier in the FS image, what you're having is that you have a particular file. So let me tell you. You have a particular file, okay, which is split into file 1 as well as file 2, as well as which is split into this particular file 3 like this. 3 files. File 3 and file 1 is stored in 3 blocks. Assuming that file 1 is stored in 3 blocks. What are the 3 blocks here? Node 1 along with this node 2 and node 3 like this. It is stored in 3 blocks here. Node 1, node 2 and node 3. Okay. Now let me tell you one thing. This data node is assuming that this data node is dead. this node 1 is dead here. Node 1 is dead. Node 1 is dead, and obviously what is happening is that I'm trying to shift this entire process to this particular node. I'm trying to shift this particular entire process to this node 6. Okay, then obviously what should happen here? Wherever the node 1 is there, I obviously has to be changed to node 6. How it will be able to change this to node 6 is my question here. Are you able to understand, Sarvan, my question to you?
Yeah. How? Okay. So when it, I believe it replicates that those blocks from node 1 to node 6 basically, because node 1 is dead. So a copy of those blocks will be there in one of the second data nodes also. So that will be copied to data node
Yeah,
6.
I agree on that one. I agree on that one. But what happens is that next time when the client is approaching to access this particular file, I should not have this particular name node 1. Instead of that one, I need to have this particular name node 6 that should be existing here, right? I need to have this particular name node 6. How this is going to happen here is this name node 6, once this is initiated, okay, for every 3 seconds it will send a heartbeat interval, heartbeat it will send, and for every 30 seconds it will send the block report. Okay,
Right.
so within that particular block report, what is going to happen is that what are the changes that has been done, it will be maintaining these particular changes here. The changes from the previous state to the current state, those particular changes are being maintained here. How exactly it is being maintained, I will show you here.
Okay.
It is being maintained like this. Like I have this file, sorry, it says that transaction 1, within this particular transaction 1, your file 1 is now existing in name node 6, okay, and this particular name node 1 is deleted. Name node 1 is down. That information is being maintained here. Okay. Now what it will do is that after every certain period, what happens is that this particular edit log what you are having here is being used to update this particular FS image here. Update this particular FM image, saying that what are the changes that you are having here. These changes will be committed to this particular versions that you are having this particular FS image. So what it will do is that it will come here and then make this particular changes from N1 to N6 in this particular case like this.
Okay. So edit logs basically kick off only when a data node dies. Is that a correct statement?
No, not only that one.
Okay.
Edit log maintains, see, whenever the block report is being sent by the data nodes to the name node, okay, the edit logs will try to capture every possible change that happens in those particular data nodes.
Oh,
every possible net in the sense that that a client has deleted a particular file. Okay. That means that those blocks are obviously will be deleted in those particular nodes, right? Basically, those blocks will obviously be deleted. So when next time when the name node sends that particular information to the edit log, it says that this particular file is deleted. So those changes will be maintained here. It is just like the log table what you maintain in the database, right? What you maintain in the database. Just like that, this will be maintained. This is something like in the case of a database, whether it is commit or rollback, those particular things what you're having, the same information is being maintained here, and every entry of this particular edit log is used to synchronize the entities that are there in this particular FS image basically.
Okay. So this is very similar to the checkpoint in Oracle basically.
Yeah,
so,
commit and rollback, checkpoint and commit point and rollback in Oracle. Yeah, the transaction logs.
Okay. How often the edit logs actually change the FS image, or how often does it happen? Every time
actually,
block.
the duration is actually 1 hour. 1 hour.
Okay.
1 hour. But we can try to reduce it to 30 minutes or 15 minutes also as well. But in high critical systems, it will be even in seconds duration also it will be changed. It's not a problem. So guys, you understood what is this FMEJ on this particular edit log, and what exactly is the name node is being maintained in this particular case? Are you clear on this part? Please let me know if you have any questions.
Ravi, if node 1 at later point of time comes up, what will happen?
Node 1 comes up.
So it is dead at this point of time.
Okay.
So will it come up, right?
See, until unless there is a manual intervention that happens, it will not obviously be coming up, right? Basically, it will not
Node
be
1
obviously be coming up.
permanently dead. So it will not no longer be node 1 after that time.
No. After the maintenance happens, then only the node 1 will come. After maintenance happens, then only the node. That means that there should be some manual intervention where the people need to go and then check, and then they need to up that particular machine, right? Basically.
Yeah, right. Yeah, it has to be done at some point. See, some set of nodes are down. Some manual intervention, whatever it is, like they will bring up all these nodes. Then how does the master manages this already dead nodes?
How does the master manages all these dead nodes?
So my question is like, will the node 1 be again a node 1 after it comes up after manual intervention?
Obviously, right? Node 1 will always be a node 1 after manual intervention. Yes. Node 1 will always be a node 1 after that manual intervention.
Before it goes down, yeah.
That is the place where the administration comes into the picture. Administration comes into the picture. See, obviously what I have told you, I have told, let me tell you here, two things here. If this is a process related thing, suppose I'm not talking about storage, I'm talking about process related thing. Okay, so what happens when a particular program is running on node 1 and assuming that that particular node has failed, obviously what would have happened here, another node would have come up, and the data would have been transferred to that particular node and that new node, and then the process would have been completed on that particular node, right? If this is a process related issue. You got this, Murli, what I'm saying? Yeah. If this is a process related issue, so your thing is done. Even then, if that particular node 1 comes back, by that particular time, the associated program would have completed its execution over there. But if this is a storage related thing, then this is the call of the administrator. Then it is the call of the administrator to make sure that which blocks has to be maintained and which blocks should not be maintained. That is the call of the administrator, basically. You got my point?
Okay. So node 6 is not known till the node 1 is dead. Is it like automatic bringing up the node 6, instantiating a node 6 upon a node 1 is dead?
Yeah, it should be automatic. Yes, it should always be an automatic.
So it should know ahead of time. There is something called node 6, right? Master should know. So
yeah, master should know. Yes.
How many of, like, it is possible that many, like in this 3 node thing, like 2 of them are down, let's say. So like how many total exist it should it know ahead of time, right?
Obviously,
like, even though like
obviously it should understand. Yes, it should understand.
Okay.
That is the role of the administrator, basically, right? See, one thing, at any point of time, okay, if a particular node is getting down, okay, at any point of time, if a particular node is getting down, okay, then it is the duty of the administrator to spin up another machine and then to bring up that particular data. Okay, so now the new node has come. After some time, if the old node is going to be re-invoked once again, okay, how should be the replication factor that should be maintained? That is something that the administrator need to take a call. Maybe what happens is that if the node 1 comes up once again, what happens is that okay, there might be a place that where they want to deactivate this particular node 6 also as well. Otherwise, let me tell you one thing. assuming that node 6 is not there. Okay, I'm having only the node 2 which is already existing here. Node 2 which is already existing here in this case. Okay, in such a case, what I need to do here is see here. In such a case, what I need to do here is this is running as well as this is running. Okay, at some point of time, assuming that this is failed. Okay, assuming that this is failed, then what I can do is that if there are if the corresponding replication is available here, okay, then I can ask the client to initiate the process on this particular node 2 and then complete that execution. In such a case, there is no need to bring up a new node also as well. Okay, trying to bring up a new node, okay, or not trying to bring up a new node is totally dependent on the network bandwidth what you're having and the call of the administrator and what are the settings what they make. But however, even though you may have 2 nodes or you may have 3 nodes, but ultimate result is that you need to maintain the same replication that has been specified in that particular parameters modeling. Okay.
Okay.
Got it?
Yeah, got it. Yeah.
Yeah. Any other questions?
One more question, Ravi. Why in Hadoop the architecture is that like all this metadata information is there in the RAM? I mean, in Hadoop 2, has that changed? I mean, and Hadoop 2, are there multiple name nodes, or there also there are not multiple name nodes?
There are multiple flavors. I'll be discussing that one tomorrow. See, there is one thing called as a secondary name node. We have the check node. We have the backup node. There are multiple variations that are there. The new variations what has come in this Hadoop 2 that I'll be discussing tomorrow, and then we'll go ahead. No problem. Yes,
okay.
The variations are there.
Okay.
Okay.
So that means in Hadoop 2, only one question on Hadoop 2. So in Hadoop 2, that means name node is not a single point of failure then in Hadoop 2.
Name node is always an active node, which is always a single point of failure, but we are having the other supplements that are going to make sure that this name node is up and running instantaneously. Yeah.
Okay, instantaneously. Whereas in Hadoop 1, it is not instantaneous. You have to transfer the metadata to the second.
Exactly.
Okay.
Exactly. Yeah. Okay, guys. Thank you so much, and wish you a good night, good morning, and we'll meet tomorrow. Okay.
Sure. Okay. Thank you.
Thanks. No problem.